Okay team, here is a short video on some feedback for session 1 of what you've done on your sax so far. So let's get to it, because I'm sure some of you need help. Alright, so some things to remember that we need to be able to do. So just some simple applications of Pythagoras' theorem. Alright, so if we've got a situation where you've got some known sides like so, maybe some fractions in there, when you apply your Pythagoras theorem formula, you need to ensure that you work with the whole sides that are given in the problem. So lay it out something like this, and then make sure as when you square each part that you're squaring the fraction, the numerator is squared to become 90,000 and the denominator is squared to become 16. Okay, and then from there we just have to simplify, and that could be done on the calculator. Remember things like circumference of the circle, okay, pi times diameter. Now if we've got a circle, or maybe two semicircles joined together, hint hint, the part in the middle there, the diameter, well, how can we work that out? So let's say we know that the circumference is 600 altogether. So then 600 will be pi multiplied by the diameter, and so the diameter is simply 600 divided by pi. What do you reckon? Okay, if we're thinking about working out the total time of a journey, well, first off, time is just simply distance divided by the speed. Now from that, let's consider a situation. We've got two parts to the journey, from A to B and then from B to C. Now if A to B is 20 meters at 4 meters per second we're traveling, and the B to C journey is 40 meters long at 5 meters per second we're traveling, so what will be the total time? First off, let's break it up into two parts. We've got the distance divided speed of the first part from A to B, and then plus, add on, the distance divided speed of the second part. Okay, and it gives us these two fractions that we can add together. Alright, now when we talk about interval notation, we're setting it up and writing something like this. Okay, and make sure you have here that we use this sign. X is an element of instead of equals. So that's the correct notation that we need to ensure we do for that such a situation. So let's consider a length, and again we've got three parts to it. We've got point A, point B and point C. Now let's say that the total length from A to C is 500 meters, whereas the first part, A to B, that's just X, some unknown amount. Then that makes the second part, B to C, has to be the difference between the two, 500 take X. So then what could be the appropriate domain for X? Well, first off, consider the fact that X, well, it's a length. So lengths, they must be positive. You can't have a negative length. So we can say that, okay, X has to be greater than or equal to 0. But then, how do we get the most largest maximum value for X? Well, consider what's the largest possible length of the line. We've got the largest length is the total length of the whole line, 500 meters. So X should be less than 500. And then we can express that in interval notation like this. X is an element of, square parentheses, 0 to 500. Close parentheses. Okay. Now, when you come across this type of problem where it says show that or demonstrate that, okay, how do we address them? Remember, if we've got a simple problem like this, if 3 plus x is equal to 5, then show that x is equal to 2. Well, that might be simply done by doing something like this. X equals 5, take 3 equals 2. Okay, but part B is when the x number is used in something else. Solve 3x plus 2. Well, you might think, oh, I don't know what 3x plus 2 is. I don't know what x is. How do I solve that? Well, think about what we got in part A. You were told at the very beginning in part A that hang on, show that x is equal to 2. So x has the value 2. That's the answer to the problem. X is 2. So you're allowed to use that answer in the next question. Just because if you weren't able to do part A and you weren't actually able to show that x is equal to 2, that's okay. Just use the answer and as part of the value to answer part B and then part C and then part D and so on. It's okay. Don't be scared. Alright, so you'll get something like this. You put in the value and off we go. Simple. Alright, so things to remember. Please remember to just, simple things like write clearly and neatly. No scribbles. If you're using grey lead and you make a mistake, that's okay. Rub it out. But don't leave big scribbly messes over the place, because if the examiner can't read your work, you're not going to get the mark. Now, make sure when you give results that we give them back to the, using correct units of measurement. So if we're talking about a length, make sure you write 4 meters or centimeters. And if we're talking about time, make sure you give your answer as seconds, 10 seconds or minutes. Okay, simple things like that. You have to relate your mathematical answer back to the physical problem to explain the situation. And that's it for now. I hope you can think about those ideas, and good luck with the rest of the task.